Okay. Can you hear me? So any question, we just move ahead because oh, mm, nobody's coming up with a question. No question. Okay, let's move on. Right. We use sheet that would help us in carrying out our projects successfully. Today, I'll be talking about Gantt charts. Right. Gantt chart is important. Very, very important. Is a visual representation of, right? What it does is that it outlines tasks, the start date, and most times the tenure. Yeah, sometimes you can have the end date also, but if you, of course, if you have the start date and you have the tenure, or the tenure is also known as the time frame with which that particular task could be completed. So if you know the tenure and the start date, of course, you can always get the end date. So a Gantt chart will show you all that in a visual representation, right? So it's very, very helpful, right? It helps for visual planning, resource allocation, task dependencies, right? When I say task dependency, what do I mean? If you remember in the last class, while I was trying to do a project schedule, right? I told you that some task must finish before some other task, right? Before some other task starts. Those tasks that must finish, those tasks that must start after the other tasks are finished are said to be dependent on the tasks that must finish before they start. I don't know if you get what I'm saying. So if a task needs to finish first before another task starts, right? The task starts to start is said to be dependent on the task that must finish before it starts. Okay, so a Gantt chart helps you see all that more quickly, right? Sorry, has the recording for this class started?
Yes, it does.
Okay, thank you. So, so Gantt chart helps you in doing all that, and in Excel, it is pretty simple to do that. I'm just going to delete this particular one I have here, and I'm going to show you how to do. This is just if you, I would have used certain projects that I've worked on, but I really don't want to do that because I don't know how far this will go. So, and I don't want to get things out of. But this is simple stuff. It's the same procedure, it's the same process. Please, can you mute yourself, Kenny?
Another ball for me because you've done a great job.
Okay. Please mute yourself, please. Okay, so usually what you would have a work breakdown structure, WBS. That's what WBS is all about. And you hear about it most times in the project management setting, WBS, which is work breakdown structure, right? Work breakdown structure simply explains how tasks are broken down. A given project is broken down into tasks, into little portions that can be given out, right? In order to get the whole entire project at the end of the day. So that just it. How a given project can be broken down is known as into tasks is known as work breakdown structure. So these are the tasks, these are the start date, these are the tenure. And from this, we can create a Gantt chart like you're going to see in a few minutes. Okay, if you are to create a Gantt chart, the first thing you want to do, right, is to go to Insert, right? Is to go to Insert, right? And click on this Insert column. You can see here, or bar chart. Click on it. You see a drop down arrow there. Click on it, right? Then when you click on it, you see a 2D bar, right? What we are looking for is not a clustered bar, right? It's a stacked bar. I believe you all see you all see my R. Yeah. So you click on that, right? And that brings this out, right? Then after this comes out, what you need to do, right? If you notice, we didn't put any data into this bar chart we just inserted. So now you need to add data to it. So you go to select data, right? Under select data, you see this comes out, this select data source, right? The dialog, the box comes out, right? You click on add. Under add, you see a series name. So the first thing I want to do is to add a start date, right? And I'm going to, you can see that series name, I wrote start date, series values, right? Under series values now, I'm going to impute all those dates. I'm just going to click on the first cell that contains the start date and bring it all the way down by pressing Shift and arrow down button, right? Okay. Right. Then you also want to add the tenor. So series name is tenor, right? Then of course, the series values, you go to tenor, you click on the first, and you do the same thing as what you did for the start date. You take the entire portion there, which is from cell 2, right? C2 to cell C13, like you have there, right? And you click OK. That's not all, right? Under horizontal categories, right? You want your work breakdown structure to show there under horizontal. So what we just did is for the vertical columns, right? What we want to be on the horizontal column or the category is the work breakdown structure or the task. So I go to edit. You notice here there's an edit under horizontal or categorical axis levels. Click on the edit and you click on the work breakdown structure. You take the entire cells there, right? Just like you did in the earlier stuff, and you click OK, right? Having done that, you simply press OK. So if you notice now, the chart that you inserted earlier has been populated, right? But what you need actually is not, in fact, let me do a few cleanup to this particular chart, right? I don't want these lines. These lines are of no help to me, or are of no use to me, right? Well, if they are useful to you, you can leave it. It's not, because it simply quickly makes you notice the dates, but they are not very important. Let me increase this. They are not very important, but for clarity, for the case of this, I'll just remove it so we have something clean, right? Then if you notice, right, what is most important, or what you want to be saying, is probably the start date and the end date. You don't want these blue bars. There are blue bars there, right? But you don't want those blue bars because they don't contain the information that you need. The information you need is just when the project starts and when the project ends, which is represented by this orange column, right? So what do I do now? I simply come to this blue, right? And I right click it, right? Which brings out this, and I say no fill. So under fill, click on fill, right? Go to no fill and click on it. The same thing, no art line, right? And that is exactly what you want. So this is your Gantt chart, right? And also you can see this task. This task is starting from the last task to the first task, which should be the opposite, isn't it? You should have from task 1 to task 3. So what do? I simply right click it, right? Format chart area. Okay, give me a minute. Let me take this out of here so that I'm seeing. No, that's not what I want. Right? You see the numbers where you have the numbers, right? Click it, right? Go to format as is. It brings this up. Format as you can see that, right? Under this, you see, if you go down, right, you get categories in reverse order. So that's the part you want. You want to make it start rightly, right? Such that task 1, you have task 1, 1.1, 1.2. So you just click on that categories in reverse order. It gives you exactly what you want. So with my task 1 starts somewhere around on the 30th of December and ends somewhere around, if this is 9, somewhere around 10 or 11th. Right? Right? You're quickly able to see that task 1.1, right, which is possibly the design stage, right, starts between the 30th of December to somewhere around the 9th of January. Why the design stage? I'm just thinking that 1.1 is the design, right? So it can be anything, depending on how you break down the work structure, how you break down the project. Then 1.2 could be anything, but you can see that from this, without looking at the chart, looking at the, what is it called? The table, right? From this chart, you can tell that task 1.1 and 1.2 ends about the same time, right? And I can also tell that task 2.1, right, is dependent on task 1.1 and 1.2 finishing before it can start, right? The same thing with 2.2, right? And so on and so forth. Picture, you can choose to change the colors of each of the cells if you want to. All you need to do is to go to that particular bar, right? Like if you notice, I just clicked on the second, on task 1.1 now specifically. Now I can change the color. Let me say the fill now. I want it to be blue, right? It just gives me some form of, it just helps me quickly. So if there's a particular stage that you are that you want to make yours, you can do it by changing the color of the bar, and that helps a lot, right? That just makes it right. Change the colors. Basically, so of course this is a mini project. This is more like a sample, but irrespective of how the project is, right? The bigger the project, there's what we should expect is that there will be a lot of tasks, right? could have as much as 100, 150 tasks, right? So you have several bars coming up like that, right? Irrespective of different colors will just help you, right? And of course, naming it particularly, right? You're saying task 1, 1.2, 1.2 because those breakdown has not been, we're not seeing what is it called, a B scenario. If not, you would have called the task 1 a specific name, let's say design stage. Maybe the task 2 is implementation stage. Maybe the task 3 is something. So you just call it a specific name, and that really helps in the old design. Okay, I think that's clear. If there's any question, please. Okay, your hand is raised, Dr.
Yes, thank you very much. I just want to ask a question.
Okay.
If you look at the chart now, we'll see that task 1, the start date is January 1st. So I see no reason why December should be included. Shown on the dates,
You are very correct.
December 10,
You are very, very correct. Thank you for bringing that to my notice. So let's correct that.
Thank you.
The project actually started 1st of January, isn't it? So you right-click that column, that horizontal value as is, right-click it. Right? Right-click it, right? Then go to Format as is, right? Under Format as is, you see this, right? Minimum, maximum, major, minor, and so on and so forth. But my start date now, I already know is 1st of January. So I don't want all this. Okay, this is how Excel, when Excel sees a date, there's how it reads it. And this is how it reads it. Of course, you as a human being, you don't understand those codings, right? But Excel also understands when you put an appropriate date there. So I go there, right? And I put an appropriate coding. Let's say 1st of January 2024, right? And I click out of it. If you notice, it changes all of a sudden. It changes, it just makes, thank you for bringing that to my notice. As in, well, why didn't go? As it just quickly escaped me, yeah.
Okay.
But that's how you do it. Does it make sense now?
Yes, please.
Yes,
okay. Thank you. Okay, thank you. So let's move on, please. Somebody answered. Your answer is okay. Go on. Go. Doc, you can go on, please. Your hand is raised.
Sorry. To close it. Sorry, I don't have any question.
Oh, okay. So, quickly, 10 to 15 minutes. Let's look into project risk, right? Let's just look into that quickly, then we move on. How to build a template for project risk. Let me increase this size. Let's see. It's pretty easy, so I might not be able to go over it from beginning, but I've taught you everything that you need to. If you remember, I taught you formatting the last class.
Yes, please.
With a list. So basically, that is what you need to do this part of the table, right? This part of the table. So the slide that I really want to talk about is this formula part, right? Which I've also explained in the first class, if you remember. Okay, the use of can't ifs, right? So let me take this off now, and let me show you how to do all that. Okay. Okay, let's do that now. So if you notice, this is a table, right, that helps you count what you have down here, down in the task, right? Take, for example, in task 1, I have complete and I, right? Whenever I have complete and I, where is complete? This is complete, and this is high. So this table will count 1. That is what this particular portion, all right? Right? And that also helps me calculate the percentage of risk. So this is a risk total, and this is percentage of each risk. So that makes you understand that, oh, this risk is high, and we need to do something about it. Oh, okay, this risk is manageable. Let's just work with it. I don't know if you get what I mean. So if I come here, I've sent this template to you before in that same project management stuff I sent earlier. So that's why I didn't send it again, because there was no need, right? You could go back and check it later. Okay, so how do I make this start counting as it should? So how do I create a formula for it? I create a count if count is, right? So count is simply means counts if it meets this particular criteria. What is the criteria? So count is right, is equal to count is the range, first of all. Let's say I, the risk, right? Oh, it's not doing what I wanted to do. Sorry about that. So count if this count if this, right, is equal to, right, not started. And sorry, give me a minute. So count if F1 to F37 is not started, and if G1 and if G1 to G37, sorry, why is that? If this is I, if this is not started, equal to, oh shit. Sorry, just give me a minute. I don't know. It's highlighting everything, and that should not be Just shift down is supposed to create what I want. Okay. So is equal to okay, you can see what is here, right? Not started. It's equal to not started. Not started. And also, right? If this, so it meets two criteria for it to count. If this is equal to I. Okay, there's a problem there. So count if F11 to F35 is not started and G11 to G35 is equal to I. Okay, that should give us the answer. That should give us the answer, right? Count ifs F1 to F37 is not started and G13 to G37 is equal to I, okay? We found a typo in your formula. I'm trying to correct it. Yes. Okay, let's see. So this is what we did, right? F13, which is status, is not started, right? And also G13 to G37, right? Which is red, right? So each time you have that, let's take, for example, we come here, right? Not started. And risk level is high. You have one here. Please give me a minute. I'm sorry, just give me a minute. Let me sort out my daughter. Just give me a minute, please. Sorry, guys. So sorry. Okay, please. Let's move on. If you okay, let's do this. Let's do for the next stage now, so that you get what I'm saying, right? If you notice, putting this formula has also added the formulas for the others. And in this case, what was simply noted there is, right? Count if, right? F13, which is this point, right? To the last point, which is if is not started, which is what we have here in the row, and also in the column if it's medium. So it has a count. So each time those two conditions are met, right, it is counted up. That is what this whole portion is supposed to do. So if I go further and I continue populating, let me say, for example, task 9, and I have not started. If you notice, let's go back and see. For not started and low, for example, we have 1 there, right? So if I go down now, not started and low, if I go there and do not started, and I come here and I put low, where's my low? Risk level key. Okay. What is supposed to be there? Okay. Okay, let me say I take I, for example, right? Not started an I, right? And I come here. If you notice, not started and I has increased to 2, right? If I take not started and medium, not started and medium is, for example, is 2. So if I take not started and medium again, right? With that, the count would have increased to 3, right? So that is what that does for us. Let me go back and fix this. I expected that load to show up. So let me fix that. Data, right? I explained all this the last time. Data, right? Data validation. Under the list, let me be sure that the list is well taken of. But the list is supposed to show from here. The list is supposed to show from I to medium. Okay.
Intended at 14, it's supposed to take 15.
Then?
The previous one was 14, intended on 14.
Yes. That's why I'm trying to correct that now, because I just noticed that obviously there must be something wrong. Okay. So I have one not started and low here. If I go back and I have not started and low. Okay. What I should have done is to, okay, I've corrected this now. I should have dragged it down so that it affects the rest. Okay, rather, sorry guys. I should have applied to all of them and not just that particular box. So let me do it again. Data validation. Selection contains more than one type of validation. Erase current. Okay. Right. So what you want to add is a list and the source now. Right. We go to high, medium, and low. Right. And you click OK. So with that, I can do not started and low. Okay, so that has come for us. It has been corrected. So with that now, I now notice that my not started and low becomes 2 rather than 1 like we have before. So if I have complete, for example, let's go to complete. add that counts up. So if you put your first formula, it affects the rest, right? It affects the rest gets plus. Like in this case, like we can see here. So let me put complete and I first and see. So this is how I completes, and this is I. Right? Complete high. Okay, that means this did not get its formula. So you apply the same formula to all of them, right? In this case, equal to, you can bring this, sorry. You can copy this, bring it here, equal to. So in this case now, right? But here in progress. So in place of not started, you should put in progress, and in place of, yeah, I still remains I because that is along the column that we're looking at. Okay, so sorry guys, just give me a minute. So this is not started. Okay, but for this one now, right, in progress, right, and that should be I. Okay, so you could go to each of those cells and just create a formula for them, like you did for this one, in progress and high. This one is in progress, right? It's the same thing, in progress and low. So copy, right? Enter, come this way. So what we have here is in progress and medium. So in place of I, put medium there. Right? So now we have in progress and medium. If you put in progress and medium anywhere else, you see an increment. In progress and medium. Right? So you can see that in progress and medium has become 2, like we have here. So you add that formula to all of them, and it gives you what you need to get. Right? So in this case now, it is complete, complete and high. So okay. So that's how you do it. With that, you're able to draw a risk formula. And as you do that, there is your percentage here, right? How do you calculate for your percentage? Your percentage is simply whatsoever you have, right? Your G5, right? Divided by your G10. Take for example, whatsoever is the total you got from this row, right? Divided by the risk total. That's how you get your percentage. The same thing with this. Whatsoever you have here, you have 3. So your percentage should be G6 over G11, right? Because you have 0 here, it has not shown, but of course, sorry, let me see that.
I think there is a mistake somewhere.
Yeah, let me look at that.
They are not correct except the first one.
Yeah. G6 over
it was 3 over 14
G11.
times 100.
G10. It should be G10. The total is G10.
You said G10.
Yeah, the total, all the total should be G10.
Yes, it's
No,
G10, not
the
G11.
total is 14.
Yes. Okay.
Okay. Yeah.
Can you see that? That's where the mistake is coming from. So I should have put an, I don't want to touch that. There's how you handle that so that the cells don't keep moving, right? It's called you absolute the cells, right? So that it doesn't keep counting. You put a $sign there, right?
Yeah.
But let's not go there because we don't have that time. So that's what you do, right? Simply just ensure that all your answers are correct. You get what you need to get.
That is correct. That is
okay. So that's it. So that's it for project management. I think we've spent so much time here. So please let's go into data analysis. Okay. To be frank with you, I've learned a lot during this 3 weeks, right? And then it's been nice. It's been nice. Really, really nice. Okay. So we are here. Let me reduce the, this is the data set we'll be working with, right? Though a few things has changed there. I prefer, let me see if I can get I've inserted some things here. I don't know, should have, let me get book 2. Something, let me show you how I got those things so that it will not look like. So what we're working on is the Titanic data set. And I want to show you exactly how it was before I started adding those things that I added, right? Because those things are, I added it and all the rest is going to be beneficial for you. So I wouldn't just want, I just noticed that they are still there. I thought, okay, what am I going to do? Let me just delete those things that were not there before, rather than looking for a plain, because we need the time. Okay, to be frank with you, this was not there. That's why it is called new survive. So I'm just going to delete it. P class, new P class was not there. So I'm going to delete it. Which other thing was not there? That is it. Okay, so this is the Titanic data set. I'm going to be carrying out and what we call an exploratory analysis on what's on the Titanic data sets, right? And just a few things, right? If you're looking at a data set, the first thing you want to, just looking at a data set doesn't give you any, doesn't help you in any way. That's what I'm trying to do. It doesn't help you in any way. So you really want to have something in mind while trying to explore a data set. What we probably might call a question or even a research question. So question is, why are you looking into the data? Why did you even choose that data? Those are important questions that you want to ask yourself before you even start doing any work on a given data set, because take, for example, in fact, the question will determine the type of data set you should be looking for, you should be requesting, right? Take, for example, I want to know how different factors affect sales in a given company, right? What I need there is not employment data set or employee data set, right? What I should be asking for is what? Sales data set. So I can't just tell them, give me all the data set, especially now that privacy is very, very the thing, especially in a country like UK, right? So they want to ask you a specific question. Why do you want that particular data set? And how would that help the company? How would that? So you need to give reasons why that particular data set should be given to you. So take notes. When you are exploring any data, the first thing you want to ask yourself is, how does this help? How does this help the organization? How does this help me? What do I want to get from this, right? So that is the first question you want to ask yourself. Why trying to do any particular analysis? Okay. Okay. So take note of that. Take note of that. Okay, so the first thing you want to do, right, or we need to do in this class is to add something to our Excel. Normally, this does not come in Excel. It's called adding, right? You need to add what we call data analysis, analyze data to your Excel sheet. So if it's not there, if it's there, you would see it somewhere around here in data. Oh. You see it somewhere around here in data, and you see data analysis there. Can you see it? Yeah. But if you don't have it, let me quickly explain how you can get it so that when we start working, you will know, you will have it and you can use it if you need to. So what you do is that you come to File, right? Under File, you go to Options, and this comes out. Then you go to Add-ins, right? And other add-ins, this comes up. Then you click on Go. If you click on Go, this comes up, right? You see Analysis Toolbar.
Excuse me, sir. We are not seeing what you are clicking.
Okay, please move
Not
this.
sure.
We are not seeing it at all.
At all, please.
Okay. Thank you for bringing it to my notice. Okay. Yeah, that's because the document I shared earlier, I've forgotten that I moved away from that. Sorry about that. Let me stop sharing and share the right thing. You know, I was working on the project management document. Now we're doing, sorry about that. But you should have said it since. Okay, so are you seeing it now? Are you seeing passenger ID, survived, P class, name?
Yes.
Yeah. Yeah, sorry about that, really. My mind was, I'm still sharing, right? And okay, so like I said, what is important is that for you to do some analysis, data analysis in Excel, right? You need to do an add-in, and the add-in is called data analysis, what you have here, right? So I'm going to add that now. So I want to show you how to do that, how to add that data analysis add-in. So you come to file. Under file, you go to options, right? Under option, you come to add-ins. And other add-ins, you click on go, right? Under go, you have several stuff here, like analysis 2-pack, analysis 2-pack VBA, Euro currency tools, server add-in. All these are very important, right? They are very, very useful. But let's concentrate on just what we need for today. Analysis 2-pack, that's what you need, right? Just click on that and click OK, right? If you do that, right, for those of you that are doing it, you see that data analysis will pop up under this data like you have here in my stuff, right? Okay. And that's going to help you a lot because you're going to see what we're going to do with it. Okay, now let's look at the data set, right? Under data sets, right, when you're looking at data sets can either be what we call categorical or numerical, right? So when I say categorical, what do I mean? I mean, it could be in it doesn't represent a number. Yeah, that's the best definition. It's not a true, yeah, it could even be a number. What you're seeing there is 1, 2, 3, but right? Yes, and sometimes it's even called ordinal. But let's leave all those. I don't intend to bore you with all those many. So what I mean is, take for example, I say first, second, third, right? First, second, third. 1 represents first, 2 represents second, 3 represents third. Even though they appear as numbers, 1, 2, 3, they are not exactly numbers. They are telling you that is in a position. This is in a first position. This is in a second position. This is in a third position. Unlike, so take for example now, those kind of numbers, you cannot add it together. You cannot say first position plus second position. So even though it's a number that's there, 1, 2, 3, right? It's telling me about something else. Apart from having a number that represents something else, you could also have words, right? You take, for example, these names. These names are categorical data. Yeah, they are categorical data, or what we call qualitative data, right? Why is because they are not numbers, right? Okay. And also, we have what we call numeric data. Numeric data are also called quantitative data. Why is because they are numbers, right? And those numbers, they can be summed, they can be added, they can be subtracted. Normal numeric arithmetic principles can be worked on those numbers to get certain results if there's a need to do that, right? So when you are looking at a data set, right, another thing you want to ask yourself is which of these, each of these column, for example, represent what we call a feature. Maybe I'm not pronouncing it right. So F-E-A-T-U-R-E, a feature or a variable, right? So we have how many variables here or how many feature here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 variables here, right?
Please, can Chukuma just mute his mic, please?
Chukuma, please, can you help us? Thank you. Okay, so we have 12 variables here or 12 features here. So you want to ask yourself, what does each of these variable or feature represent? Is it a variable? Is it a numeric data? Yes, just beyond. Take for example, in this first variable, we have 1, 2, 3, 4, 5, 6 to whatsoever. Is that what is that? Is that a numeric data or a categorical data? Because what you can do with that particular data, right, is dependent on the kind of data that it is. What you can do with that particular variable or feature is dependent on if it's a categorical data or numeric data. Okay, so you can get quite a lot of information from this, and let me show you how we could get this using basic statistics, using the data analysis which we just imputed into our Excel sheet. Take, for example, the first row, right? I want to get this first row. Let me get from here down, Control Shift down to get the entire. Go on, your hand is up. Olato, please go on, Olato Bison. Bison, go on.
Yeah, good evening. I discovered that the data set you are working on, I couldn't have it here. I don't know. Do you just send it to Ox? I don't know. The data set
I sent it to everybody yesterday. I believe we
Yes.
all got it. Did we get it? The rest of us, please. Did we get it yesterday?
Yes. It's via mail.
Okay, so I sent it yesterday. You could go back.
Excuse me, is it via mail?
Yes, via mail, of course.
Okay, I will check it. Thank you.
Okay. So data analysis, I just clicked on data analysis now for those of you that just, okay. Then what I'm interested in is descriptive statistic, right? I want Excel to help me describe that particular variable that I just highlighted, right? So I click on descriptive statistic and I click OK, right? And it brings up this, right? And then it's asking me, what is the input range? Of course, input range is there already, right? Output range, where do you want to put it? I want to put it in N4, that's okay, right? And what am I concerned about? Sometimes this is not highlighted. In fact, what you will usually see is something like this, right? So what I want is actually summary statistic. Ensure that that is ticked, right? If I don't tick it, let me say, for example, I don't tick it. See what we have. It tells me descriptive statistic. Please choose at least one statistic option, right? So I need to tick it. So summary statistic, and I click OK. Output range, we overwrite existing data. Press OK to rewrite data in range. Okay. Let me see what I have here. No, this is not. Sorry. I think something happened. So let me redo it so that I get. Okay, let me see if I can push this out of here. Okay, let me do it again, guys. Just give me a minute. So data analysis. What happened is that there was something there before. In fact, let me delete this. I don't know what happened there. Let me delete that. Right. Okay. So highlight this from here down. And I go to data analysis and I click on descriptive statistic. Okay. Summary statistic, everything looks okay. I want the output to be, okay, let me put it here, right? And I click OK. So if you notice, a lot of information came out that helped to explain that particular passenger ID, right? That simply is passenger ID, right? So let's look at the mean, for example. The mean is simply 29.69, that's 29.7, right? The standard error is this, the median is 28, the mode is 24. But what might interest you, for example, is something like the counts, right? The count is 74, 714. The sum is this. The maximum is 80. The minimum is, sorry, this is not correct. Guys, sorry, please. This is not correct. Why? Is because the minimum cannot be 0.42 when we have minimum here as 1, right? So there's something wrong there. Let me do that again. All right. Come on, what did I not do? The script says that okay, right? Yes, showing F instead of A. What I'm interested in is A. Sorry about that. I thought that was highlighted already, right? You put it there, right? And you click, I think the rest are correct. Okay. So this is exactly what I'm looking for. So this is the passenger ID. Right? It gives me the mean. The mean is 446. It gives me the standard error. What I'm concerned about is the counts. First of all, you understand that in the data set, you have 891 rows. So even without scrolling down to the last row to know, okay, how many rows do we have in this data set, this already tells you, right? That is 891 rows, right? Apart from that, which other information can we get? The sum of the rows. The maximum number that we have there is 891. And if you look at this, maximum number we have there is 891. Count we have, how can you have maximum as 891 and count as 891? Let's go for one. And also the range. You know what range is? Range is a subtraction of the maximum, of the minimum from the maximum. So 891 minus 1 gives us 890. That is the range. So it just seems like what this number is about, it's just a continuous counting of 1 based on what we understand from this summary that we have here. And if you go back to look at it, right, it's just telling us that it's simply 1, 2, 3, 4, 5, 6, 7, 8, 9, and so on and so forth. So basically, this is a categorical data. Why? Is because is an ID more like. So even though it's a number, right, it's used to represent an identification, some form of identification for somebody, right? And this summary will help us to know that. Okay, let's go to the next, right? Let's go to the next. Okay, under survived, you see 0, 1, 1. You see zeros and 1, right? Looking at that, for the limited numbers that you have there already, 0, 1, 0, 1, 0, 1, 0, 1, you already know that that's obviously a categorical number, right? Yes, is there is a number, but it's representing something else. So what does it mean? 0 simply means perished, and 1 simply means survived. Right? If I carry out the same analysis I did for the first person, let's say I do that. Let's do that quickly. You will notice the difference. And if you notice in this first passenger ID, there is no mode, right? those are things that quickly tell you, okay, possibly there's something wrong. Do you understand? Things like that just begins to draw your attention to, okay, look at data set again, look at possibly what could cause that and all the rest. So let's look at this survived and see if that will give us any information. Go to survive. What we're interested in is from this down to the end. And then where do I want to place it? I want to place it in, what just happened? No, please. Sorry, guys, just give me a minute. And be sure that this thing doesn't come out. Okay, so I want to put it here. Let me put it just under, right? Summary statistic is ticked, and I click OK. All right. If you notice here, right, look at the counts. Counts is still 891, just like you have here, of course, right? And then the sum is 342. But look at the maximum. The maximum is 1, and the minimum is 0. So it just simply tells you that all we have is 0 and 1, right? And of course is 1, right? So when you see an information like that, you begin to ask yourself, oh, what possibly would be happening there? That doesn't look right. That doesn't look nice. So it just tells you that it's a categorical data, basically, right? Okay, let's now look at, of course, you're seeing male and female here, right? You can see P class. P class is the same thing. You're seeing 3, 1, 3, 1, 1, 1, 2, right?
Sorry, excuse me. Sorry for interrupting your.
Go ahead, please.
Okay, for the passenger ID, the reason why the mode is we have non-applicable under the mode is that if you look at the passenger ID, no number repeats itself. We have 1, 2, 3, and we are talking about the mode. We are talking about the highest, the occurrence number. 1 appears 1, 2, 1. Yeah. Are you getting it? So definitely mode is not applicable in this particular data, this categorical data. All the numbers it appears just 1. So we have 1. Am I communicating? So that's why we have
of course, that makes so much sense, right? That's very correct, right?
Very correct. Yeah.
That's very correct.
Exactly the scenario, the case. Then the second one, for the survived this thing, it's a categorical data and it's also a binary. You only have 0 and 1. So definitely there's no need of looking for the sum, looking for the minimum or maximum. So definitely we don't really need all this. We don't even need to look for any mean because we know that it's a binary. It's supposed to be 0 or 1. Are you getting it? So
okay, well, I'm doing this because we are just looking at.
I know.
Yes.
I understand.
So
I'm just trying to shed more light.
Yeah, I'm doing it because I'm trying to get more info. So you know how to, if you see a data set, you know how to look at it, how to check it up to know, okay, is this, even though it's a number, is it categorical data, is it numeric data? You understand? And the mode makes sense. So that's that. When you talk about the mode, the most foreign number, when you talk median, you're talking about the center number. So what's divided by the number of digits, right? So let's move on. Okay, for P class is the same thing as what we have for survived, right? P class is same. Yeah, the ticket type or the class of tickets, which is either first class, second class, or third class, right? Right. The sex So that tells us that even though it's number that is showing there is a categorical data. That's what I'm trying to say. Then for the age, let's look at the age quickly. Right? Let's look for the age. Of course, age would certainly be in numeric data, right? But let's just see it so that it makes sense. We can distinguish it. We can see the difference between what we have there and what we add in the rest. So if I do control down.
Sorry, please excuse me.
Okay, go ahead, please.
Yeah, looking at the age, I think there is a row where we have a blank. Does it mean there is no age attached to the person? Like
yes, that is what it means, right? That is what it means. I would say something about it. In any data set, right? In any data set, there's what we call missing data, right? So you should expect it in any particular data set, right? So there are several ways of handling. I will get there. Just give me a minute. I will come back there very soon. Okay, so the outputs now. The answer to your question is one of the reasons why I'm doing this, so that we'll see it. And you observed quickly, actually. Hold on. Okay, this is age. Let me name them so that this is age. What was this? Let me ignore that because it's not relevant. Okay, if you notice now, right, in this count, we have 714. Right? Remember that in the previous counts, we'll be getting 891. But in this particular case, we have 714. That means there are several missing data rows that we are not filled. All right. And there are several reasons why it's possible that those rows will not be filled. Maybe while the person was filling the ticket form, he didn't fill it, he didn't write his date of birth, or he gave a date of birth that's okay, it's too high. It's possibly let's just believe that for it not to have been yet, that means the person did not write is right. So because of that, rather than 191, we have missing columns there, which is over 100 and something, right? That's a lot. And there are several ways you can handle
sorry, excuse
data.
me, please. I also want to add something to that. You know, this space we have 714, definitely we have over 100 missing values. So from that 714, I think I saw one pledge that is even below 0 point something, which is not possible. From that
You saw 0.42.
Yes.
Okay, yeah. Do you know what?
Yeah.
I agree
that
with that.
is another
I agree
thing.
with that.
That is another appliance. Maybe we have to treat it with that missing value because it's not you know, one cannot.
Okay, let me explain that, please. Let me explain that. You're being very observant on this.
I just saw it now.
Yeah. Let me explain that. You know, of course, when you give birth to a child is 0 years, isn't it? 2 months into the child, is it up to a year?
No.
It's not up to.
So we can give it some form of fraction, isn't
fraction, it? Yeah, fraction age, yeah.
So 0.42 is allowed, please.
Okay, months. Okay,
yes.
0.4.
So that represents some form of month. Yeah.
Yes, it's possible.
As a fraction of the year.
Exactly.
Yes, it's okay. Yeah.
Okay, let's move on. So that is already telling us that there are missing data there. And I was trying to handle the issue of missing data quickly, even though we don't have all the time. But when you see a missing data, one of the things you want to do is possibly replace it with a mean, median, or the mode. right? Those are different quantity that you might want to represent it with. Okay? And what are the factors that determine? Of course, there are a lot of other methods, right? I can tell you about interpolation. You interpolate it and you fill it in. Interpolation, I don't want to go into that details. Let me deal with the simple ones, right? Which is this use of mean, median, and mode, right? Some people do the drop, they just drop that missing data row, right? Take, for example, I have 891 rows, and by the time I counted, I noticed that over 100 rows is missing because of over 100 rows is missing in a particular variable, right? Because of that, I take away the 100 rows that are missing. You know, that is a great loss of data. Understanding that data is not easy to get, and whatsoever you do to your data set is going to affect your final result in one way or the other, right? Whether you are dropping it or you are replacing everything with the mean, median, or mode, irrespective of what you do, is going to affect the way your result comes out, right? But you just have to take a decision. You just have to take a stand, irrespective of what the situation is. So either way, you decide what you want to do. If you think you have enough data set after you've dropped those rows, it's fine. Go ahead and drop it, right? But if you think, take for example, what we have here, just 891 rows, right? You want to consider again before dropping anything. You understand? So we're not going to drop it. We're not going to do anything with it. Let's just leave it there. Let's just move on. But I'm just telling you the different methods that you could use to replace the stuff, this thing, if you need to. And if I want to replace each of those data sets, what would I have done? Like I said, so that I don't forget myself, I'm trying to run, so I'm missing out many things at the same time. Take, for example, when do you replace it with the mean? You replace it with the mean when you notice that it is that the data is a normal data. What do I mean by normal data? That means, sorry, just give me a minute. Let me see if I have anything here to show to you. Important elements. Let me see. If I have that information there. I thought I saved some information there. Okay. Normal data. What normal data will do is that it will give you a curve. It will give you a curve. Just give me a minute. I'll show you something. Right? When you plot the graph of that, if it gives you a normal curve, that means it's a normal data, and it's a normal distribution rather. If you have a normal distribution set, you place it using a mean. If you have a non-normal, right, which sometimes is called non-parametric, right? It is, you replace it with the median. Then if it's a categorical data, you present it with, you replace it with the mode, right? I think that's the best I can say about that. How do you tell if it's a normal data? You possibly will plot it and all the rest, but this is not enough class to explain all that. And let's just move on with what we're doing so that we can cover along this line that we're already going. But take, for example, I want to present this. I want to replace this data set. Let me show you how to do it. Like I said, I don't want to replace it because my data set is not plenty. It's not, I just want to leave it like that. I just want to work with it like that. But if I'm to replace it, for example, with the mean, what is the mean in this case? This is the mean is 29.69, which is 29. You can just say 29.7. All I need to do is to do Control H. Highlight it. Highlight that particular row, right? And press Control H. All right. Control H is more like a find and replace dialog box, right? And when you see find what, right? Find what, in this case, we are finding those empty spaces. In those empty spaces, you can replace it with 29.6. Is it 6 or 7?
7.
Right? And I click
Replace all.
replace all. Okay, let me start with replace all. Right? And I click, you can see all finished. We made 177 replacements. That means it was 177 rows that was missing. And I click OK, right? And I click close. With that, all my spaces are filled with 29.7, 29.7, 29.7, and so on and so forth. Should we work with our data set like this? You said?
I think it's better we
I would
continue
like to
like this.
ask this question. Hello?
Yes.
Is it possible the age? Is it possible the age we have age like 29.7?
I think he has explained that.
I think I've explained that.
In months.
Sorry, please.
Like for example, when we have 28.5, which means the person is 28 and a half years old.
28 years and 5 months.
No. When we have
28 months.
28.5, are you getting it?
28.5,
The person is
6
28
months.
years, 6 months. You know, we have 12 months in a year. And when you're talking about this is 100, are you getting it? Am I communicating?
Yeah,
We've
gotten your points.
Yes, if somebody is a year, just 1 year, it's 12 months. Whereas if somebody is now 0.5 months now, it means that the person is 6 months.
1 year and 5 months.
Yes. 1 year, 12 months, it will now be equal to 12 months will now be 1 year. Are you getting it? So 6 months will be 0.5.
What you just do, let me tell you what you do. What you do is 0.7 times 12. 0.7 times 12, right? That should be about 0.7 times 12. That should be like 7 point something or 8 point something. So that should tell you that it's 8 months.
8 months.
9 years, 8 months. You understand? Yeah,
sorry, please.
Your basic mathematics. Basic mathematics will come into play there, and quickly know how many months you're supposed to add to the years, right?
Sorry, so please. I have a question.
Okay, go ahead.
Yeah, please. With what we've just done now, does it not affect the integrity of the data itself?
Okay. You remember, yeah, I understand what you just said, and that's a very good question. And I remember saying that anything you choose to do if there's a missing data has a way of affecting the integrity of the data, right? If you drop the data, good and fine. Question is, yes, dropping the data would be very helpful and have enough rows of data. What you want to work on, right? Between the integrity of the while considering, so if those, right, the next thing she should be considering is whether go on with.
And we also have to consider whether the data is normally distributed.
Sorry, give me a minute, please.
We have to check for the normality of the data first, so that one will not give us the hint whether we are going to use the mean or not. The mean has different value. For example, here, our mean is, I think, where is the mean? I think we have 20 something points. 21 is, I think mode is 24. One is 24, one is 28, and the other one is 29 point something. So if it is normally distributed, I'm talking about the data now. If we plot the graph and it is normally distributed, right, definitely we are going to use the mean. Otherwise, we'll consider other things to use. We are not testing for the normality of the data now. We just assume that, okay, let's just pick this value of mean to be something.
Yes, please. I didn't put that normalization. I just told you that so that to keep you informed of when to use the mean, the median, and the mode. And please, I don't want those.
If the data is normally distributed, we can replace the missing value with the mean.
Yes, that's what I
getting
said earlier.
Yes,
Yeah.
already.
So about the data integrity, right? Yes, is a general principle that you could do this. There's a method you could use in, and that's just about the best you can do. So yes, why that would quite affect the results in a way, right? But if properly managed, right, we can still get something good out of everything, right? So it is something that generally accepted, right? Okay. Olushola, please go ahead.
I just want to be clear. What if the data is not normally distributed? What will you do? Sorry.
You represent it with the median.
Okay. Thank you.
Then if it's a categorical data, you present it with the mode.
Okay. Okay, good. Thank you.
You're welcome, sir. Okay, let's move on. Have I done everything I needed to do? Yeah, basically that's it. All right. Okay, so there are a few more stuff here. We have tickets, right? Even sometimes even the name tells you, okay, if it's a categorical data or a numerical data. Take, for example, that ticket. Ticket cannot be a number, of course. That's more like the ticket number. So that must be a categorical data, right? Then fare, right? Fare is, you could also check it using this summary statistic, whether it's a categorical data or what it is, right? Abin. And embarked. Embarked is where, who is talking? Are you saying something? Are you asking a question, Busi?
No, not at all, boss. Continue.
Okay. Embarked is where they dropped off, where they came into the bus, the point at which they joined the flights, right? That's where they joined the what is it called? Where they joined the ship, the Titanic. Okay, so let's move on. So one of the things that really do help you in analyzing categorical data is the pivot table, right? And I'm going to talk about that quickly. And it's going to be helpful for you while trying to analyze categorical data to see how this can be useful when carrying out exploratory analysis. So I'm just going to copy the data set. Where do I come to? Let me come here. I don't want everything here. So, or let me just put it by the side. Okay, so this is the cell. This is the cell, right? Like I've explained to us earlier, this survive, for example, 0 and 1, right? We present survived and perish, right? So instead of this survive, I want to have that, I want to replace it with survive and perished, right? So I've created a new column now, right? Let me do it again so that Of course, you right click the cell after it and you click insert, right? And with that, a new column comes in. Then you can click on that and click new survived, right? Then here, you click equal to, right? If, right? So I'm trying to populate this column now, right? If this, right, is equal to 0, right? That is perish, right? Is that perish or perished? What should I use? Anyway, that's the English. Let's not perished. Okay, otherwise the person survived, right? Because we have just 2 there. So it's either 0 or 1. 0 perished. The rest survived, right? So let me correct. Oh, Jesus Christ, what did I just do? Oh, okay, it has opened.
It has populated.
Yes, it has populated, right? So can you see that?
Yeah.
So with that now, where you see 0, you see perished. Where you see 1, you see survived, right? So that's what you have. The same thing with P class. P class also, I want to also populate it, right? Insert. No, I want it to come after, not before it. So right, so this is new P class. Right, and in this case, because we have just more than 2, right? Because we have more than 2, what we should have is ifs. What we should have is ifs, right? So ifs, if this is equal to 3, right? We put third class, right? Let's just put third rather. Third is sufficient, right? This is part of what we call pre-processing. For those of you, it's part of what we call pre-processing, and you do this a lot while trying to work on data, right? Facts. Generally,
Sorry,
if you get it
to say data cleaning.
yes, it's data cleaning. It's part of data cleaning, pre-processing, right? Whatever you call
All right,
it.
thank you.
Yeah. Just to make the data up to the standard that you can work with. Just give me a minute. Please, I'm coming. A minute, please. Sorry that today is just a bit, I'm so sorry about that. Usually not like this. My little girl is at home and the mom is not around. So I need to take care of her. Okay. So P class is equal to 3, and that's third, right? Then the same thing, when P class is equal to 2, right? We have second. Then when P class is equal to 1, right? We have first. Right? So we see that that has brought that up for us. And we've added a lot to our data set already. Right? So now let's go, like I said earlier, in trying to understand a categorical data, right? It is important that what helps you in doing that is called a pivot table. All right. Let's just use a pivot table to understand the idea behind what we are trying to, the research question here, or the question we're asking ourselves with this data set is, what factors affect this survival? Yes, what are the factors that could make somebody perish and the other die, and the other survive, right? Rather, do you understand? That's what we are trying to ask ourselves with these data sets. So what affected it? Is it the sex? Is it
I could see that
you said?
those people, majority of those people that are in the class perish. Majority.
Sorry, I didn't get that.
And I just, from the look of, they're looking at the data. Third class.
Okay, a lot of third class died, right? Okay, we'll see that better, right?
Yes.
Okay. So let's insert a pivot table, right? What is the range of data? The range of data is this, control down. Yeah. Do I want an existing worksheet or the present worksheet? Let me do it here. Yeah, let me do it here, right? Okay. Okay. So now I have this, right? Our passenger ID survived, new survived, P class, new class, and all the rest of that. So what do I want to look at? I want to look at sex, right? Let me bring it to the rows. And as I added that, you can see female and male there, right? Let me also add new survived. Let me add it to column, right? So you can see perished, survived, grand total. Let me explain this quickly, right? Anything I drag and drop in either these rows or columns, right, adds a dimension to your pivot table, right? In data science, there is what is called dimension, and dimension is what helps you understand the data, right? Dimension is each variable you add to either the rows or columns adds to the dimensionality, right? Currently, I'm working on a project, right? And what I'm studying is I'm trying to study how, you know, sometimes you get very big, large data sets, maybe like you have over 30 rows. I mean, 30 variables or 30 features. But what you need your data for, or what the part of the data that you need is maybe 5 or 6. All right. That's called, so how do you know the most important 5 or 6 rows with which you can get the answers to your question, right? It's part of one of the things that's important in data analysis. It's called feature reduction or dimensionality reduction. But let's not go into all that. Let's just stick to, so like you can see in this particular, I've added 2 dimensions, the sex and the new survived, right? And I can also add this new survived to the values, which gives me more like, which explains, okay, in the female, look at it, in the female, I have perished, I have 81, survived, I have 233. That's a lot. A lot of females survived, right? This is already giving me some information about the data, isn't it? Like, okay. And for the male, right? 469 perished, 109 survived.
Right.
Can you see from just this simple thing that we've done already, we're already getting, and if it was 1 million data roll, it would have mattered, right? Just doing this would have just brought it out for us like this. And we're getting amazing insight into the data already. So with this, I know that, oh, obviously more female survived than male.
No.
Right. Okay, I could take it further to ask myself, okay, if this is the case, what other things can I break this down? Okay, how many females survive in first class, second class, third class? That is another dimension. So I can add it to, you can see new P class. Let me add it to the rows and let's see what it comes up. So with this now, I can see first class, second class, third class, right? First class, second class, third class for male, for female, and for male. So with this now, I know that 3 people perished in first class, just 3 women perished in first class, while 91 survived in first class, right? In second class, 6 perished, while 70 survived. That's for the females now. Then in third class, the same number that perished survived, 72, 72. Can you see we're already getting a lot of information out of this stuff, right? Then let me go to male. For male, in first class, 77 survived. 77 perished. That's a lot. Why just 45 survived? So in second class, 91 perished and 17 survived.
What did men do for God?
What did men what did men do? It's been like that. That's life for you. Okay, let's stick to this, please. Just leave the prejudice. Okay, third class now, 300 died. And so basically, we're already getting all this that we've dragged down are majorly categorical data, right? But it has given us a lot of information into the data already. Do you know what? I can bring back down to know also how the different place that they got into the Titanic affected the number of people that died. Just like, so I'm increasing the dimensionality. That's what I'm simply doing. So with what I have already, I have 3 dimensions here, right? I can add 1 more to make it 4 dimension. Right? So with this now, I know that people that entered, sorry, the name of these places, I'm not so used to it, but I saved this somewhere so that I could help myself in calling the correct thing. I can't find, okay, I think I should have it here. Okay, the same thing I have here, there is what I have here. So let's use, okay, so this is it, right? C stands for, is that Chebonk, Queenstown, and Southampton. All these are UK places. So these are the different places where they all got into the Titanic. So we noticed that just 1 person that got in from Chebonk perished. 42 of them survived. That means a lot, right? Queenstown, just the one person that entered from Queenstown for female survived, right? Southampton, 2 people that entered from Southampton died. 46 survived. So with this, we are getting amazing information already. Do you agree with me?
Yes, please.
Okay, can we move on, please? Because we're already far behind. I've not even gone. Okay. Let me hide this thing. This thing is disturbing me right now. Sorry, if you need to raise your hand, I might not be seeing the dialog box to see the people that are raising their hand. So just possibly unmute yourself and draw my attention. This thing is just, it's obstructing my, I need to have a better, so I have to minimize it. Okay. So with that now, it gives me a lot of information about those stuff, right? Okay. So with that, we've been able we've created a pivot table. That's how to create a pivot table. So if I ask you to create a pivot table next time, I believe you know what to do, right? The pivot table is a great way to explore categorical data. Yeah. So let me take that out of the way. And also, something I forgot to tell you before is that, you see this, instead of having this, I could decide to change it to percentage. So let me say something like this, right? I could right click it, right? Instead of having numbers, of course, numbers are great. You could decide to work by numbers. You could decide to work by percentage. So if I decide to work by percentage, I could right click it, right? Go to value fit settings, right? Under value fit settings, show values as, right? Then you see show values as. You can click on that. Percentage of row total, right? Can you see that? I can click on that and click OK. So with that now, everything is coming in form of percentage rather than numbers. All right? So I just thought to drop that. So let's move on, please. Okay. So now we've dealt with that. Let's talk about histogram. The use of histogram in creating this old stuff in viewing. And histogram is a powerful tool. It's actually very useful when you're dealing with it's numeric code data, right? Just as we're going to see in a few minutes, right? Let me create it first, then I'll do further explanation. So take, for example, this is the age. This is what we're looking at. Let me just highlight it from there. Let me come to insert, right? Can click on recommended, right? If I click on recommended, I can see this, right? A histogram shows the frequency of occurrence values within. We can see histogram there, so choose on it. Yeah, click on that and click OK. Right. So bring it to one side. You can see it has done an amazing job for you. What has it done for you? It has grouped the data for you, or the ages rather for you. It has grouped the ages for you, and it has told you the number of people that falls within that range. Take, for example, between 042 to 6.12. That's why I didn't want to, in fact, if you notice, this was not the replace data I did, because if I had put that 29 point something, that's why somebody was talking about data integrity. It is that either way, data integrity would, especially if you're not dropping the rows, right? If I put 29 point something, that means this column now, 28.92 to 34.62, would have been much higher, because that's 177 numbers that were replaced, they would have appeared here. Right? Do you understand what I mean? Yes, they would have added to this between 28.92 to 34.62. So let's say we had 177 here. That would have been like, do you understand?
The bar would have gone higher.
Would have gone way higher than this.
Yeah.
Yeah. So actually, it affects it a lot. So you want to be careful while dealing with. You can drop the row split, drop it. There are other methods like interpolation, which I would prefer, right? But of course, it's much complex. It's not an easy task. And in fact, most people, even in data science, don't understand that interpolation scenario, right? So, well, let's leave it. Okay, so this is my histogram. I'm going to remove this line in between because I don't need it. Sorry, give me a minute. Let me remove that so that I can have it clean. I'm going to increase this so that we can look at it carefully. So this is histogram. It quickly gives me the different range, right, that we have. Different range that we have. And we can see quite a lot of amazing things from here, which I'll show you in a few minutes. In fact, from here, okay, let me start from this. Take, for example, I click on this, right? If you notice the bin, right, in mathematics, there's what is called bin width, right? Bin width is telling you, okay, between what range to what range is this particular, is each of the bar, right? So yeah, we have 0.42 to 6.12. That is called the bin width, right? If you do the subtraction, 6.12 minus 0.4, that should be about 5 point something, right? Okay. I can change that bin width. Let me say I'm not comfortable with this and I want to change it. How do I do that?
That's the question I wanted to ask.
I know you
Can
will
somebody set
it's favor, right?
interval, the age interval? Can
Okay.
it be set?
Yes, it can be
For
changed.
example, I can decide to change, okay, 0.00 to 6.00.
Okay, let me show you how to do that.
To have, constant.
No, but it must be constant. You know, it must be
Yes,
constant.
of course, I know it must be constant.
So if I right click it, right, I come to format as this.
Okay.
Right. It brings me to this column. And under this column, you can see by category, automatic, bin width. Click on bin width because that's what you're interested in. So you find out that the difference that they are currently working with is 5.7.
Okay.
Right. So if I don't want 5.7, let me say I want 10. Right. And if you notice, it has changed. Right?
Yeah.
It has changed the shape of my graph. It has changed quite a lot. And the truth is that why doing something like this? You want to change, you want to have a smaller bin width because having a smaller bin width would help you in seeing the true picture of things. Because take, for example, between 0.
I observed something from the graph.
Okay, go ahead.
Okay, the first one is 0.42, to 10.42. So if you look at the second bar, it still has 10.42.
Yes, that is the beginning point. Histogram
is supposed not to be like that. Sorry, because assuming we have somebody that has 10.42 here, where am I going to plot it? Assuming I'm using manual method. Because it has already fallen into two bars now, the first one and the last one. Let's say I have 10.42 exactly as a point, one of my observation, one of my age, right? And I decided to plot it here. Then, do you still want me to plot this in the second It's quite, I don't
Okay,
know.
let me explain that. It's favor, right?
Yes, please.
Okay, let me explain that quickly. This is histogram, isn't it?
Yes.
Yes, basic mathematics. Histogram starts from a point and ends at another point, and the next bar starts from that point. Right?
Really?
Yes, check your
I
histogram.
beg
Check
to
your.
differ. It's my field.
It's not bar chart. It's histogram. That's
I
what.
know. Okay,
Mm.
histogram is the one that the bars are jointed together.
Exactly.
Why the bar chart? Each bar, stand on its own.
Yes.
Okay, maybe we should just continue, but I beg to
Yes.
differ.
Favor. See, what I just told you now. Check it. When you check it, drop it at the
I
group
will
just
check
to
it.
confirm.
Because in a station whereby when we are setting a class interval or a class
I get what you're saying, right? I get what you're saying.
if it
If
stops
it's
here, then the
10.42,
next value would supposed to be the next one. For example, now when we have 0.42 to 5.42, then the next one supposed to be, the next number, not that 5.42 will still repeat itself in the second, group. I don't know.
Well, histogram, this is how it's usually plotted. And I understand the issue, the question you just raised, right? But most of the time, we really don't have that problem because there's something called interquartile range. Is that where it applies?
Interquartile range and all that. But this is,
Yes.
I don't want to argue, but
Okay, let's not. It's not.
The class interval is not well.
Well, but this is what you have if it's histogram and it's plotted.
This is histogram.
Right? And thank God I'm not the one plotting it.
I know, I understand.
So,
but it's supposed not to be.
Okay, I just noticed a few questions was asking in the chat. Sorry, I just saw it. I believe the people are still here. Let me just quickly answer that. Mute your mic, please. It's distracting us. Why median or mode? Somebody was asking why median or mode. Yes, those are some of the what should I call it now? Those are some of the things we use in replacing missing values, right? Because those things, median, and mode gives us a generality of the data of the set of data that we have, right? Take, for example, the mean. The mean tells you, okay, this is about the average, right? Mean is majorly the average. Median is, okay, when you share the numbers into two, after arranging it when you share the numbers into two, after arranging the numbers in ascending or descending order, what will be the middle number? That's the median. And the mode tells you about the most frequent occurring number, right? And those are key important elements when you're looking at any data. So they could as well be used for replacing any missing data. So I think I've answered that.
Okay, excuse me, sorry for cutting you short. I think this one is using class boundary, not class interval. Yes.
Is using what?
Boundary.
Yes, that's what I said now, being with, isn't it?
It's boundary. We have class interval, we have class boundary, we have, it's using boundary. Okay.
Okay, that's fine. What is the difference between count if and can't ifs, right? Count if is when you're dealing with just two elements or two features, right? You see that in, okay, let me explain. So count if is when you're dealing with just two elements. Count ifs, right, comes into play when you're trying to put in more than two elements into the discussion or into the consideration, right? What I did with count ifs, right? I can also do with count if. If you remember the first class I did, I used the count if to segregate. What did I use that count if for last time? Okay, I used it to segregate to tell if a certain class of people has A B, C, D. I use count if for that. So what I used count ifs for today, right? If you listen to that my class properly, you can also use count if to do it, right? But count ifs, the one with the S now, makes it easier for you to do that, right? Without creating a very long formula like I did that day, right? I hope I've answered your question. Okay, please, let's move on. We have quite a lot and we're just, but I've answered your question. I want to answer your questions. It's important that I answer those questions. I don't want to leave them pending. But if you have any question, you could still drop them in the Excel WhatsApp group. I would respond to them. Okay, let's move on with this, please. So you can change the bin width like I just did there, right? Format axis, come here and change to 5. Like I said, make the bin width small because it helps you capture more details about the data set than if you make it big, right? I think I've explained that earlier. So this, if you look at this gives you more information than what you have there because that summarized it more. Okay. And if you have a chart like this, you can apply what we call slicers. I don't want to forget that. You can apply a slicer to it. So go to data, right? Sorry, give me a minute. Let me be sure. Sorry, go to right. Right. Nation file on this, in the workbook connections. Yeah, you should be able to apply slicers. Sorry, let me see one more time. Slicers would help you a lot. Hold on. Okay, it's like slicers is only applicable for bar chart. Sorry, we'll get there. I'm not gotten there. I think I'm mistaken. Okay, let's go to, we've done that. Let's go to bus plots. There's something called bus plots, and that is also a very useful tool, right? Right. There's a lot we can get from bus plots, right? I remember talking about normal distribution earlier, right? And bus plots will help you understand if a data is normally distributed or not distributed, right? And all the rest. In a bus plot, you have what is called interquartile range, right? Give me a minute. Yeah, you have what is called an interquartile range. This is the interquartile range, right? Where you have this box. It's called interquartile range, right? And you have interquartile range lies between Q1 to Q3, right? And usually you see this tail, from this tail to the box, right, is 25%, right? And from this starting of this box, this Q1 to this Q3 is 50% of the data, right? And from this Q3 to the end, the last quarter, which is another 25%. So from this tail to the first line of the box is the first quartile. Then from this Q1 to this Q3, right? We have this Q1 now represent the 25 percentile, right? We must have heard of 25 percentile. It just tells you, okay, the first 25% of the data lies between this point and this point. Then 50% lies between Q1 and Q3. and the remaining 25% lies between this Q3 and the other tail. And every other thing that lies outside those tails, like the beginning of the tails and the end of the tails, are called outliers, right? What are outliers? Outliers are simply, yeah, this is what I was looking for earlier. Okay, outliers are simply things that part of the data set that looks either too big or too small. They seem not to fall into the range of data that we have. They are take for example, you have a range of data that's between, let me say 40 to 60, right? And all of a sudden you are seeing 200, right? That's obviously an outlier. Or let me take for example, you are seeing age, like in the data set we are seeing now, we are seeing age, and we see somebody age, we see an age of maybe 1,000, right? Of course, that kind of age should tell you that there's something wrong. Nobody hardly to live up to 1,000 years in this current age and time. So that's obviously an outlier. So outliers will usually fall outside these box plots, right? And it's being represented by these dots like you see here. Okay, how do you plot an outlier? Okay, I was talking about normal distribution earlier. Look at it. Let me explain that quickly using this. Normal distribution, if the data, you see, in this case, right, it looks like between these points and this point is another, I remember I explained that between this tail and this point is 25%. Between this box represents 50% of the data. But in this 50% of the data, there's another line that separated it, right? This is the 50% mark. So that means between this tail to this point, we have 25%. And between this point to this average of the box, we have another 25%. And between this average and this end, we have another 25%. I don't know if you get what I'm saying. So whenever you have a data where this point now to this 50%, this 25 percentile and this 50 percentile has the same data set or the same data volume, that's the word, the same data volume as between 50 to 75 percentile, you have what is called a normal distribution. And usually, if you plot it, if you draw the graph, you have something like this symmetric. You can see symmetric here. Yeah, you have something like this. But this is a very good. Let me continue my explanation here. You have a symmetric, something like this. All right? Where it looks like what you have here is equal to what you have here. The same volume of data you have here, the same volume of data you have here. So if you have maybe like 50, between 25 to 50, you have 50 between 50 and 75. Okay, but we have what is called left screwed and right screwed, right? If we have left screwed, that means more of the data is between the 25 to 50 percentile, right? So in that case, you see that this line now is drawn towards, yes, more of the data, it looks like it's in this part, right? Compared to this other later part. Then we have what is called the right screwed, something like this. And in the left screwed, you can see this. More of the data is here, right? And in the left screwed, more of the data is in the right hand. I believe that makes sense. But yeah. Does that make sense? Okay, I haven't said that, right? I want to create a bus plot so that you see how we could do something like that. How we could do something like that. Okay, I'm going to delete this. Okay, so I want to create a bus plot now. What do I do? Remember that what we are trying to, and in the bus plot I'm creating, Box plot helps us in looking at numerical data against a categorical data, right? So take note of that. When you want to compare when you want to get more information about a numeric data compared to a categorical data, box plot becomes important. You could use box plot for doing that. So how do you go about that? You simply come to insert, right? You come to, I'm trying to get both again. Sorry, can't remember that. Let's do this. Sorry, guys. This is it. In Excel, it's called box and whisker. If you remember what I was explaining, I talked about tail. It's not called tail, it's called whisker, please. That part that is like a line. It's called a whisker. So Excel calls it box and whisker. But today is known as, popularly known as box plots. Okay. So now I've inserted the box plot, but I want to give it data. So I go to select data, right? I add, right? Series name and series value. Let me say series name. What is the series name? Let me say age, right? I come here to take the age. I go to series value. I take the age. Oh, that's complete. That's not looking complete. That's complete. Oh, here, I've seen the problem. Sorry, guys, just give me a minute. Let me rectify that. If you notice, I'm already using a filter here, right? I want to remove the filter so that I could have my complete data. There's also a filter here in female, so I want to remove it also. I will add it for you later so that you see what I'm trying to do. But for now, let's remove it so that's okay. So I delete the sorry guys, just give me a minute. Okay, let me go over that again. Insert. Then I have box plots. Then I want to select data, add, right, age, right, series value. So I want to add all the ages. Okay. So, and I click OK, right? Okay. So if I do that, this is what I get, right? And if we notice, there are a lot of information there, right? Or basically, it's not giving me so much. I don't want the field, so let me remove the field so that it starts looking no field. And why those many dots? Okay. So that's what it is giving me, right? It just gives me the age. What I want beyond that, I want to separate the age from the, I want to separate the survived from the perished. So I can just right click it, right? Select data, right? Edit horizontal, right? And now I take this all new survived. And I click OK. Let me see what that gives us. So with this now, you can see that with this, I've been able to get survived and non-survived and perished, right? So from these box plots, I can get a lot of information also. Sorry, let me edit this a little. Let me come here, all right? I remove the guidelines. I removed the, what should I remove again? I need to take rid of chart title. I want chart title. Yeah. Okay, so if I remove that, I think that's okay. So from here, this is just a box plot of the perish stroke survive. Then as I work on this just a bit using filter, I get a lot of more information, right? About this graph. But like I said earlier, you can see these outliers, right? Take, for example, people that perished, right? If you're above the age of 70, right, is an outlier. What do I mean by it's an outlier? Because most people above 70 did not survive. That's what that means. Do you understand? So in the data set, of course, there's somebody that's above 70 that survived, right? Sorry, this is perished. I'm looking at perished. This particular person here survived, right? So there's somebody here over 80 something, right? That survived. The person is an outlier because most of the age range, most of the people that we have is between 0 to 60 that survived. It's just one that has beyond 80 that survived. Right? Are we still together? Okay,
Yes.
let me take this. Let me take this further. I can decide to just look at. Yes, I can decide to just look at just female. Can you see how it affected the box plot? Then with this now, I now know that, okay, the number of people that was between, in fact, over 50% of the people that perished, that survived, right, is between 20 years to 40 years. Right? Over 50%, because this is interquartile wage, isn't it?
Yes.
Then also people that perished, right? They are between somewhere around 15 years, especially for female, right? Somewhere around 15 years to, this is 35, right? So that's density. Then I could also come here and say new class. So let me check for first class. Let's probe into first class now and see using our filter. First class. Okay. Can you see this? So with this now, I know that people that survived in first class that are female, most of them are between, in fact, nobody below 10 survived in first class. That's a female. Wow. Okay, I'm just saying that for the first time. Is that true? Yeah. So nobody, because I can see first class here, female, 2 years. perished, right? So this data is already telling us a lot, right? And one of the things that is telling me is that nobody between 0 to 10 or 15 years survived, right? So people that survived is maybe between 15 to somewhere around 65. Then people that perished in are between the age of what age is this now? This looks like somewhere around 2 to somewhere around 40 something, right? So a wider range perished in first class. So with this, you can filter your information and get more insight into the data, right? This is for second class, right? And this is just for female. So if I want for male, I can just go to sex and change back to male. That will give me more information about male, all right? So you can see it. A lot of people perished, right? And more people that survived for male, right? Based on this, let me reduce this a bit so that I can draw closer. So you're already making inference. You can see that people that survived, and we're looking at second class, the people that survived in second class, right? Most of them are children. Okay, children survived actually, not that most of them. You can see quite a lot survived there, right? So it's not true that. So quite a lot of people survived, right? In for male. Then the people that perished, no children perished. Did you notice that? Yeah, there's nobody here that's a male that perished. No child that's a male that perished in second class. So the age that start, okay, the people that perished, right? That's male in second class, start from about maybe age 15 and to somewhere around age 55 or 57, right? So it just gives us interesting insights into the data. Don't know if you get what I'm trying to say. Let me put on. Right? Any question based on this? I think what, and if you could try and draw something like this by just screenshotting each of them and pasting, right? But this can be better done using R actually, right? Where you now map each of them, female, right? Sorry, give me a minute. Let me take this away so you can see. So this is female, right? This is first class, second class, third class. And this is male, first class, second class, third class. When you're looking at it this way, the survived and perished, it just gives you more information and you're able to look at all of them at the same time. That's what is called visualization, isn't it?
Yes.
Okay. Lastly, I will touch scatter plots and we'll call it a day. And in scatter plots, rather than using yes, I would have gone back to use the what's it called, Titanic data sets. But Iris data set helps us a lot in this, and it's going to explain what I need to explain so that you get more insight into scatter plots, right? So I'm just going to touch this scatter plot using the Iris data set, then we'll call it a day. There are more things I hope to explain, but I can't cover it, please. It's already almost 8:30. Okay. So box plot is a very wonderful stuff that helps us look into a given data set, right? It gives you a lot of information about a given data set. And let's see how we could use that in looking at this, for example, all right? So let me say I go and I impute scatter plot. Look at it here, scatter plot. Or I can, let me say I want to get this scatter plot. I can alight the two features I want to get the scatter plot for. Come here and click scatter plot. All right. You can see that it has given me a scatter plot. What is scatter plot? Scatter plot is simply representing a point using two given data, right? Each of them, one representing the column, another representing the x-axis, while the other representing the y-axis, right? So this is a scatter plot, and I'm going to show you something here, right? In modeling, right, we have what is called linear regression, right? And linear regression is a model that helps you build around things and helps you get more information. If you are given maybe one of the data later, you'll be able, take for example, with a linear regression model, if I'm given just 3.2, I should be able to get 1.3, right? Using that linear regression. I don't know, for those of you that are science, you know what is called slope. You did what is called slope. Where gradient is equals to change in y over change in x, right?
That's physics.
Yeah, that's physics, right? And interception becomes c. So you have y is equals to c plus mx, right? That's what is playing out here, right? In linear regression. So I can just come here and add a line, which is called trend line in Excel, right? Looking at this graph, right? Can you see the line?
Yeah.
Right?
Yeah, we can see.
Visible.
Yes.
So that tells me that this particular relationship, right? Because basically what we are looking at is the relationship between these two variables or these two features. So this tells me that these two features are negatively correlated,
Yes.
right?
Yes.
Why? Is because if you see it, when the what does this represent now? This axis.
Why is this?
This axis represents the stepper width.
Okay.
So you notice that the higher the stepper width, the lower the
Petal length.
yes, the petal length. So it's a negative correlation.
Yeah.
Right? So if I take, for example, I plot another, and again, you notice that the more these dots are close to this line, right? The more correlated we can say that this, or the more we can say these two features are closely related or closely correlated. Does it make sense?
Yes, it does.
Let's take one more, which will help us understand that. Then I'll do something for you now, and you'll see something interesting. Let me look into these two features. All right. And I go to insert and I go to who can tell me something about this one I just dropped now?
Is positively correlated, highly correlated, because
yes.
the scatter points, they form a kind of positive system.
So it's positively correlated. So if I had a trend line, for example,
yes,
right? If I had a trend line, if you notice, all the dots are very close to this line.
Yes.
So if you have a case like this, you can say the correlation is close to 1, right? unlike this first one that we did, and they are far apart. Notice that they are quite away. So yeah, the correlation should be, yes, it should be negative, but it should be away from 1. So we should be having something around 0.3, 0.4, right? Because the dots are far away. In fact, let's do correlation so that you can see what I'm talking about. So with this, you can tell the correlation between 2 or more features. But let's see correlation in Python. For example, if you are doing correlation, which I'm going to do now. Let me do the correlation first, then I can explain Python, what you would see in Python. Okay, what did I want to do? Correlation. Okay, correlation is in data analysis. What am I doing? Okay, come to data. Come to data analysis. What I'm looking for is correlation, and I click OK, right? And it's asking for input range, which I thought I've done before, but let me still put it. Okay, and it's asking for, let me see that. Is it input in the first? Oh, sorry. Let me go back there, right? Because I need the inputs to be there. Sorry, the labels to be there, right? Okay. Then labels is in the first column. Then I want it in this same worksheet. So let me go to the worksheet where I want it to be. Okay, let me leave it here. Okay, let me put it here. All right. Let me click. Is there any other thing I need to do there? Okay. So that's how you do correlation in Excel, right? If it was in Python, it would have come in color format. What you'll have been seeing is colors, right? The darker the color, the better for you, the more correlated it is. Or in Excel, this is how it comes out in numbers from between -1 to +1, right? Okay. Where either one shows that is strongly correlated. Okay, so of course, this is sepal length. This is sepal length against sepal length. Of course, they are both the same, so they will show up a relationship of 1. But what I'm concerned about is, take for example, the one we just plotted is petal length and sepal width, right? This is petal length against sepal width, which is this stroke this. And if you notice, what you have there is minus 0.42. Of course, we've already said that negatively correlated, which is down negative there, minus correlated, being that it's far apart. So because of that, we have 0.42 something there. Then look at this one. This is 0.96, right? Which is this petal width against petal length, like we did here, right? And we agreed earlier that it's strongly correlated. You can see how you can get information out of these different plotting and analysis that we do. Now, does this make sense?
Yeah. Thank you.
Even if it doesn't,
Okay.
even if it doesn't, we
Good
can always
place.
play back and grab it. But I think it makes a lot of sense. Yeah.
This is where I would stop for today. Any question, any information? We've already overstayed our welcome. Sorry about that. Sorry for that. Past the time I expected us to stay. Any question?
Are we having class? Are we having class next week?
Yes, please. We'll have a class next week. And what I expect us to do next week is to, you see everything we've done, right? I want us to try and create something. Maybe do an analysis, do something with, if you want a data set, I can provide you a data set.
No,
That's what I was about to
That
say.
would be
If you're able to give us like an
we really
assignment.
appreciate that.
that would be appreciated.
Yeah, like an assignment.
Kind of,
Yeah.
Yes, I'll give you a data set, and you analyze it, or we've done project management, we've done a lot of other things. So more like what I want you to do in the next class is to bring your questions if you have questions, and also showcase your skills, what you've been able to learn for this past few weeks. Present it, right? So it's more like a feedback. Let me see if it has really been helpful. Like I trust it has been. So that's what the next class will be about. And it will be from 6 to 8 next week, Sunday.
Thank you
Right?
very much. Really appreciate you.
Thank you.
Thank
Thank
you.
you so much, Ajayi.
Thank you.
It's so helpful.
Good night.
Thank you very much.
You're welcome.
Thank you
You're
so
welcome.
much, bro. Thank you.
You're welcome.
Thank you. God bless you.
Thank
Yeah.
you so much. Thank you. We
As
appreciate
soon as I hope
Okay.
to get the
Yeah.
recording as soon as possible so that we can replay and digest it more.
Yes, of course, you get the recording.
Thank you so much, so much, so much.
Yeah. Okay then.
Bye.
You guys should have a great
You too.
evening. Yeah,
Bye.
bye. See you in the next class. Yeah. Please, I want to see all of you, and I want to see you present something good, because it will tell me that okay, at least we'll do something out of the class. Please, let's try.
We'll try our best. Thank you.
Yeah. Okay then. Yeah, bye.